Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to our fourth lesson, Introducing Derivatives. In the last lesson, we learned the differentiation of a function at a point. Today, we will also learn the differentiation of a function over an interval. Are you ready, students? Then let us begin. There are functions that are differentiable at all numbers in their domain. There are also functions that are only differentiable at some of the points in their domain. F prime is the function whose domain is the set of numbers at which f is differentiable. Its value at x is given by f prime of x equals the limit of f of t minus f of x over t minus x as t approaches x. F prime of x is the derivative of f with respect to x. We consider t as a variable and x as a constant. As an example, let us find the derivative of f of x equals x squared with respect to x. Using our definition of f prime of x, we find that f prime of x equals the limit of t squared minus x squared over t minus x as t approaches x. We can cancel the like terms to get the limit of t plus x as t approaches x. Therefore, we have found that the derivative of f of x equals x squared with respect to x equals 2x. Try this for yourselves, students. Find the derivative of this function with respect to x.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Applying our definition of f prime x, here is our expression. We multiply the expression by t plus 5 and x plus 5 in order to eliminate the upper denominators. The resulting expression is f prime of x equals the limit of 3xt plus 15t minus x minus 5 minus 3tx plus 15x minus t minus 5 over t minus x times x plus 5 times t plus 5 as t approaches x. Many of the terms in the numerator cancel each other. The expression therefore simplifies to the limit of 16t minus 16x over t minus x times x plus 5 times t plus 5 as t approaches x. We can cancel t minus x out of the expression. Solving for the limit, we find that the derivative of the function with respect to x equals 16 over x plus 5 the whole squared. Did you get the same answer? If you did, great job. Do you recall learning about the functional and delta notations for the gradients of graphs? Good. Now, we must learn a few other notations for derivatives. If y equals f of x, then f prime of x equals dy by dx d by dx of f of x and d of f of x. These are all different notations to express the same relationship. Using these notations, we find that f prime of x naught equals dy by dx as x approaches x naught. This equals d by dx of f of x at x equals 2x naught, which equals d of f of x naught. Make sure that you remember these methods of writing derivatives, students. Now, we are ready to learn about differentiability on an interval. If I is an open interval, then we say that a function is differentiable on I if f is differentiable at each point in I. If I is a closed interval with a less than b, then we say that f is differentiable on I if f is differentiable on the open interval ab, and if both of the one-side limits exist. For example, let f of x equal the absolute value of x minus 2. We will discover if f is differentiable at x equals 2, then we will find the intervals on which f is differentiable. F prime of 2 equals the limit of the absolute value of x minus 2 minus the absolute value of 2 minus 2 over x minus 2 as x approaches 2. This simplifies to the limit of the absolute value of x minus 2 over x minus 2 as x approaches 2. But there is a problem. The limit as x approaches 2 from above equals 1, and the limit as x approaches 2 from below equals -1. Both of the one-sided limits exist, but they are not equal. So, the limit of absolute value of x minus 2 over x minus 2 as x approaches 2 doesn't exist. Therefore, we must conclude that f prime of 2 does not exist. However, because both of the one-sided limits exist, we know that f is differentiable on the open interval -infinity up to 2 and the open interval 2 up to infinity. F prime of x equals 1 for all x that are greater than 2. F prime of x equals -1 for all x that are less than 2. It is time for our second activity. Please determine the intervals on which this function is differentiable.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again. Here is what the expression looks like after we have applied our definition of derivatives. We remove the radicals. Then we use the properties of limits to move the coefficient. Then we cancel the like terms, which gives us the derivative of the function. Therefore, f is differentiable on the interval of -4 over 3, 4 over 3. That is all for this lesson. We have learned about the differentiation of functions over intervals. Until next lesson, thank you, teacher. Thank you, students.